Okay, I'm gonna start going live here. If you want to say hey in chat, thanks to everyone who joined. There's a couple people I think hanging out. Yeah, I'm gonna get started. I'm just gonna go post about this, say that I'm going live now, but we'll get started in a second. I think I'm watching myself in. Oops. Hey, Marvin. Oh, we got a bunch of people. Hey. Hello, everyone. Yeah, I'll give folks a second to come in, but the plan is I put some slides together because I after doing SDR podcast for so long, I honestly have no idea how to present something other than in slides. So this is going to look a lot like SDR slides, but you notice the logo is different. So this is a sort of like a product preview, product demo kind of slide. But hey, Lucas. Yeah, I mostly needed to do a dry run because eventually I'm gonna record like a nice recorded version of this. So this is mostly me giving the presentation to everyone who's hanging out in chat right now, so that I can realize all the parts that I go, oh wait, I didn't explain this thing, or that folks can ask questions and I can realize what I'm missing in there. So thank you for being in the audience. This recording will stay up, so if you missed this or you're watching later, hello. But yeah, if you think of anything else, let me know, because the goal is to turn this into a, more full-featured product demo. So let me know if any of the audio levels are off or stuff like that. I'm not going to do any interactive demos today. I think I'm just going to stick to the slides so I don't tempt fate. But there is a recording on this channel from like a week ago where I'm not going to pull that down. I did some hardware demos too, so you can see what it actually looks like. So yeah, let me go ahead and get started. Yeah. If anyone has questions, let me know. I've got the chat up so I can look at stuff. But this is sort of my early preview or demo of Poststation. So I've been working on Poststation now for a couple of months. I think I started in September for a little bit, and then October and November I've spent most of my time on. But yeah, I do a lot of projects where you need a microcontroller, and sometimes more than one microcontroller, and usually there's a much bigger computer that are attached to these microcontrollers. So we're not talking about battery powered devices or portable devices. This is usually like something hooked up to motors or lighting or various equipment and stuff like that. And usually I tend to do a lot of rapid prototyping, so I'm brought in pretty early in projects, and I've done a bunch of these built on top of Postcard and postcard-rpc, and Poststation is sort of the distilled version of all the tools that I wish I had out of the box, and the tools that I will be using going forward just to make life easier for me. So yeah, I sort of think of it as the pro tools for Postcard and postcard-rpc. If you're already using postcard-rpc, chances are your devices are going to work almost out of the box with Poststation. Basically, if you can send a serial number, then postcard-rpc will give you everything you need for Poststation, but it's sort of the premium experience. So the plan is to build this as sort of a paid tool, or we'll get to that a bit more later. But all of the sort of infrastructure pieces like Postcard and postcard-rpc and the schemas and everything, those are all open source components, so that's not going to change. But this is sort of I want one really nice tool to use all of this and making projects much easier. So I spent a fair amount of time. Let me make my face a little smaller so I don't cover the slides. I've also spent some time doing web stuff. So if you have a web background, you're probably familiar with stuff like reverse proxies. So if you have a whole fleet of servers running your website, like multiple ones and databases and stuff, usually you'll have one thing sitting in front of it called a reverse proxy. So it looks like you're just talking to one website, but you're actually sort of handing out jobs to different people on the back end. And the goal is to do sort of the same thing for embedded devices. You have a bunch of embedded devices connected to your laptop or an embedded Linux machine or something like that. And to be able to treat them as entities that you can talk to and ask them to do things and keep an eye on what they're doing and tell them to do things and all those good things. But through a single interface, so you don't have to manage connections or managing what if devices drop out, or setting up the same connection for all of the devices, or as you're developing stuff, unplugging and replugging stuff, managing that, and those kind of things. So Poststation is mostly meant so your application talks to Poststation, and Poststation talks to all of the devices. So yeah, I want it to be pretty painless to work with multiple embedded devices. We've got some really good tooling in embedded Rust these days, with like ProbeRS and Deformat and things like that. But it can be more challenging if you're dealing with multiple devices or like different versions of a device and things like that. Having to go and run command line tools for all 3 or 4 connected devices can kind of be a pain in the butt. So this is sort of my ability to just run something in the background, and you never have to worry about losing your connection and things like that. So it really is meant to be run from a bigger computer. So like I said, this is probably not the thing you want if you want a very tiny portable system, although you could still use it as a development tool for that when you're plugging devices in or like provisioning them and things like that. But it kind of really shines when you have a dedicated machine, and sometimes that changes over time. Like when you're doing initial hardware bring up, you might just have your laptop plugged in, and maybe it's not as portable or hard real time as your embedded Linux system, but you can prototype stuff or set up a test stand where you're running the electronics all the time to make sure the electronics are good, while you're still in your development process and things like that. So it doesn't even have to be tied to one machine. You just need some machine that's going to be talking to all of these devices. And this is usually because I find that doing... even though you have stuff like the Raspberry Pi where you can usually do some level of connection, I find that for a lot of projects you either run out of peripherals, like you only have so many serial ports, or you only have so many pins, and then you have to add like port expanders, or you need it to support some baud rate that you can make your microcontroller do, but it's hard to make an embedded Linux system machine. I found that it's easier to usually just have an embedded Linux machine talking to a microcontroller as sort of a sidekick or a buddy. Because a lot of embedded projects, or a lot of embedded hardware, like microcontrollers, has way better documentation and drivers and stuff available than your standard embedded Linux machine. Raspberry Pi is pretty good, well covered, but once you start getting into the less popular or less well documented systems, getting them to do something that their demo projects don't do can sometimes be a pain in the butt. And It can be painful, especially if you're not already like a Linux kernel or driver developer, where if you really need the hardware to be doing something different, usually it's way easier to find like an STM32 or RP2040 and get it to do some really specific timing based or serial protocol thing. So you can really just like let the microcontrollers do what they're good at. You can pick a microcontroller that's good for spinning motors or good for reading sensors or has a ton of IO, and you can just buy whatever one makes sense for that. And the same thing in the other direction, like when you have a problem where you want to do networking, or you want to do over-the-air updates or logging, or even just prototyping and iterating and stuff like that, embedded Linux or your desktop's way easier to work with. You're not reflashing the devices. You don't have to worry about a network stack or cryptography or updating things like that. So, or file systems or databases and things like that. So you can kind of let embedded Linux do the stuff that it's good at, and you can let the little microcontrollers do the stuff that they're good at. And this is the slide that I posted on Blue Sky a while ago of, I'm kind of pitching microservices for microcontrollers. Instead of I've heard some people try and do like Docker for microcontrollers. I'm not really trying to sell you on like portable software or running WASM or something on your microcontrollers. The goal is really to treat one microcontroller like it's one microservice. So it is a little device that does one job, and it doesn't have to worry about everything else. It just goes, okay, I am told to spin the motors, and I spin the motors, or I know I'm just going to be reading this sensor forever, or I'm going to be scanning keyboard inputs or a screen or something like that. You can kind of throw hardware at problems, especially in lower volumes. I am actually going to talk about this a bit more on the SDR podcast on Wednesday, so I'll get deeper into that, but in my opinion, it's usually easier to throw a couple microcontrollers that all work together on something, as long as it's Pico services, because it's micro. I like that. It's easier to have like one little piece of hardware that does one thing. It makes your project simple. You can have 3 or 4 files, and that's your whole project, instead of trying to get them to do 20 things at the same time. So like if you're running a website, it might look something like this. You've got all your connections coming in from outside. You've got a reverse proxy that they talk to, and it's firing off those requests to different services in your backend. And this will all be in your sort of like server backend. And the goal is to get the same shape, but with microcontrollers. So you might have a bunch of stuff running on your embedded Linux system, like a user interface that needs historical data. You might have like an update service that's keeping track of things. You might have something that's managing logging, so grabbing all the logs from all these microcontrollers and throwing them up to Grafana or something like that. But those can all get routed through Poststation. So it doesn't matter how many connections you need to make. You can just have tiny little applications and a bunch of them talking to all of your microcontrollers and stuff like that. So now we're going to get into some of the like screenshots and demos. So this is what Poststation looks like today. The first main way that you have to look through things is the text user interface, or TUI. So it gives you a list of all the devices. The ones on the top there are the ones that are actively connected right now. So you can see that their state is connected. You can scroll through, and you can even see information for devices that aren't connected right now, because Poststation has a database. It remembers all the stuff it hears, which means just because you unplugged your device doesn't mean you lose all the logs or you can't go back and look at things. You can still look at all of your devices by their name or serial number or whatever and see this information, or even just as a quick look, you can see if it's plugged in or not, because if it's at the bottom of that list, you know it's not plugged in, and if it's at the top, you know that it's talking right now. Postcard-rpc and Poststation also do service discovery. So Postcard-rpc lets you say, hey, these are all of the endpoints that I have, or these are like the APIs that my microcontroller offers. And so in the user interface, you can go and say, like, what are the endpoints of this device? And you can see all the data types that it receives or sends and things like that up top. And then you just get this nice little table of like all the names of the services that it offers and what kind of data you got to send it and what kind of data you're going to get back. So you can kind of have plug and play ability here, where even if you were to plug in a device and you don't know what firmware it's running or you don't know what its capabilities are and things like that, you can just plug it in over USB. Poststation will talk to it, say, hey, tell me about yourself, and then it'll automatically generate this report for you. So you can say, oh, okay, I know that this is these APIs, which means, oh, this is the motor controller device, so I can talk to this, or something like that. So this is just sort of like a read-only browse version of that, but you can see all of the things that your device supports, and if it changes, like you do a firmware update, when it comes back, it'll get updated, and then you'll have the new schema as well as the old schema. And you can also get sort of like a Wireshark live view of things. So these are kind of published topic messages coming in, but you can see when they came in, what topic they were, and then it actually decodes the values for you. So all of the actual communication with the devices over USB is using Postcard. So it's using that really tiny binary format that's really efficient for the devices to handle. But that's binary data, and I don't expect you to hex edit Postcard data like I can, but instead it just translates it to JSON. So whatever the shape of the data is, you can just get a human readable version of that data out automatically. And we'll see where that pops out in some other places too, but it makes it pretty quick to just see live data going in either direction, so you can monitor what's going on and like the history of what data went in what direction at what time, which is very, very useful for debugging, especially if you get some bug to reproduce once and you go, what did I do to make it do that? And that can help a ton when it comes to debugging. So the terminal user interface is sort of like I just want an overview. I want to browse my devices. I want to look through it. Just kind of check that things are connected and things like that. But the next thing that you can use for talking with your devices is you get a command line interface from Poststation as well. So I've got basic commands like ls, where it'll show you all of your devices, what interface they're on, whether they're connected. You can look up their serial number. If you're going to start doing more scripting where you need to refer to them by serial number, you can get this really quick in a little text interface and things like that. The command line interface also lets you do all of the communication through the command line interface as well. So this first command up top is proxying a message. So this is sending an endpoint request to the specific device on this path with this message. And in the command line, again, you can just type in JSON. So this is a type that I think if we see this here on ping, we can see that the request is a U32 and you get back a U32. So it's just going to echo back whatever you're giving it. But if we proxy to this specific device on this endpoint with this message, so in JSON, this is just an integer, or a number, I should say, we can see that the device responds back okay, and that it's going to echo that message back to us. So we can make kind of like manual poke. So if you need to like enable a device or set some calibration value or something like that, you can just do that from the command line, which is kind of what I was doing in that demo last week, where I was setting like the motor speed and things like that to try and figure out what a good motor speed was for the kind of effect that I was doing. So you can kind of interactively do that on the command line. For stream data, so postcard-rpc also has topics or like published data, where if you're reading sensor values, instead of making someone poll you for that information, you can just, publish that information continuously, and you can also just listen to that information. So here we're listening to this serial device, or the serial number device, and then on the simulator temperature endpoint, and that gives us the device, the path, and the body of that message. So you can just see that going over time. This is the simulator. This is a very silly high temperature because it's just a running, it adds pi to a running counter every time that it prints it out. So these numbers get kind of big if you let the simulator run for a while. But it just shows like you can have live data streamed to you and things like that. And since you can put it in a command line, you can put it in a script. So if you need something that just triggers some sequence of actions really quick, like, hey, move the arm to the original position, or reset the motors back to their default state, or, turn on a sensor, turn off a sensor, or something like that, you can just throw in, works with like a Pico 2. So yeah, this should work with any embedded device that has Embassy and Embassy USB support. I've been using the RP2040. I know someone who I've given early builds to is using this on the Pico 2, so this definitely works on the Pico 2. I also expect it to work with basically any STM32 device or NRF52 or things like that. So basically anything that Embassy, the Rust embedded async runtime, supports and has USB support, today should work. And then in the future, I hope to add other protocols, so not just USB, but like serial ports or I2C or RS485 and things like that. So you have more options for talking to your devices. But yeah, you can see we're just, throwing some command line actions into a script. You could put these in environment variables or run them from whatever, but it's pretty quick to prototype. So this is controlling two different devices, setting both their motors and doing it at the same time. So this is something you can throw together little scripts for very quickly if you need to do demos, or if you're just figuring out like fine-tuning something over time. So I haven't actually shown this before, so this is a world premiere. I've hired someone to work on a graphical user interface for this as well. So all of the TUI stuff was mostly kind of read-only because I haven't spent a lot of time on it, but I'm going to be building this, which will also let you do things like build those messages. So based on the schema, if you want to send a message to the device, the user interface is going to know, oh, this takes a struct with an integer, a string, and a whatever, and it'll give you a little dialog box for this, so you can type that in, hit send, and then it'll give you back sort of the visualized data. And then for stuff like those stream messages, that temperature that I was showing before, the goal is to have live graphs just automatically for that. So you don't need to do anything to get graphs for your device. So you could just wire up your device to print the current temperature or, the brightness that it's measuring, and you'll just get live updating graphs for that, so that you can see how stuff responds over time, or like try shining different lights on it, or all of those good things. Because I want it to be easy to just have something that looks really classy really quickly with no work. And that's definitely something that this is the only preview I'm going to show of this for right now, but it's in progress, and I'm pretty excited about this. So this is something that'll be part of Poststation very soon, I hope. So you don't have to use a command line if you're writing Rust code. There's nothing stopping you from talking to your device. So I'm Am I persisting those graphs permanently? I think Marvin's asking, so the database engine that Poststation uses is Fial. The question of how long we store historical data, right now I think I'm storing it forever, which isn't something that we want to do forever. I plan to probably have configurable sizes, so like per how much data we store, so you can say, oh, remember the last 4 gigabytes of devices and things like that. For those graphs, the graphs are being rendered live. We'll probably have some kind of selector of like start time, end time, because everything's indexed by the time that it was received. So you should be able to set start times and end times, or maybe in the future we can do fancy stuff like if it pauses for a while, we can just restart the graph. Haven't gotten all the UX down on that for yet, but the graphs will be generated live from the API. So the API can make requests like, give me all of the samples from here to here, or give me all the information starting at this time, and then listening live to the live updating data and draw the graph for that. So haven't gotten the UX for all the graph stuff done yet, but that's all just coming out of Poststation as sort of like a back-end service where it's storing all the historical data. So if you're writing Rust and you want to talk to the devices, I've got an SDK for that. That's the Poststation SDK crate. It's actually public now. Doesn't help you if you don't have Poststation much yet, but you can connect to the Poststation server, give it a serial number, and you can do things like render a frame and send it. So if you've used postcard-rpc, this is going to look really familiar because it's basically the same API as postcard-rpc, except for you're also giving it the serial number of the device, because you could be talking with multiple devices at the same time. So this is something that's really easy to slap like a little driver crate around. Something I've done for clients and things like that, where you just have one driver crate that handles all of the devices and gives you a really native looking API for running with this. And this all connects over sockets to Poststation, which means you can do pretty high throughput stuff through this. It's not going through REST or anything like that. This is actually using postcard-rpc over a socket to Poststation, which then proxies it out over to the devices also in that. So you can get pretty high throughput with those kind of things. I haven't run into CPU usages or throughput problems for any of the stuff that I've been doing, and I'm excited for the first person that's streaming enough data to actually make it sweat a little bit. If you're not using Rust, I'm still not leaving you out, because I have a REST API for all of the endpoints. So like all the demos I'm showing you are on all of those interfaces. You can play with them in the TUI, you can use the command line interface, you can use the native Rust API, and there's also a REST API, which is sort of my plan right now for supporting other languages, because basically every language has a good, web request. So this is requests in Python. Basically every language has that, which means it's really nice regardless of what language your like application developers want to be using in. You can still use Poststation to talk to all of your embedded devices without your embedded devices having to speak TCP/IP or REST or JSON or anything like that. They still get the super lightweight binary protocol, and you can kind of be flexible on the computer where there's room to be flexible. So this is just looping 5 times, filling out a message as a Python dictionary with the sequence number and the body of the message. We're hitting that ping, or we're proxying a ping endpoint here, and it's going to get the response and print the JSON back for us. And we can, if we run that, we get basically what we expect. We get the response back from the device with the sequence number that we send it. I made sequence number 0 instead of I. Oops. I'll fix that for the nice one. But you can see that the number that we're giving it changes as we increment that, because it's actually sending that message back to us and things like that. And then also for the live streaming stuff, I don't have a Python demo for that, but I have got WebSocket, which is kind of like curl for WebSockets, kind of. So we can connect to that device by its serial number. We want to listen to the simulator temperature path. We give it the key of the topic. So this is like, what kind of topic do we expect this to be? And we can pipe that into JQ, and you can see that we get this stream of line separated JSON and things like that. So you could also, if you were doing your front end in JavaScript or Python or something like that, you'd be able to just stream this live data the same way. And then in the same other way, if you wanted to stream data to the device, you could also do that over WebSockets. So basically, the goal is to give everyone any option, like we'll keep the super lightweight fast protocol for talking to the end devices, but then the world is your oyster when it comes to connecting it to whatever other languages or services you have on your, embedded Linux or laptop device or whatever you're using it for. So the plan for Poststation is really kind of sell it as two different products. So one is going to be like a desktop tool for developers. So this is the plan is to sell it as like a single user license. You can buy this. I'll have a demo mode, kind of like WinRAR, where it'll just say unregistered if you're an individual and using it, and it'll bug you every now and then. But the plan is to offer that at a fairly reasonable choice. I'd like people to or fairly reasonable price. I'd like people to just have this because it's a fun tool and it makes developing fairly easy. So it'll kind of be like a standalone tool that you can use. It'll be, like I said, single user, so you can plug whatever devices you want into it for your laptop and things like that. But for folks who are looking to ship this on a device, the plan is to have, I do have a headless version of Poststation, which doesn't have the terminal interface or web interface built into it. And then if you're shipping like 5,000 robots with Poststation as sort of like your communication backbone, to be able to offer that for companies to license, so you don't have to spend engineer time building up all of this plumbing and the nice like developer tools that you can still use and things like that. So I'm kind of planning on it being a tool that individuals can use, but then also something that if you want to actually ship this in production in a robot or in an industrial system or something like that, to be able to have that as an option for you as well. So in terms of timeline, I've been working on this. It's certainly a 0.x level quality right now, but it's already something that I've been using for the last month or so, even on demos and personal projects and things like that. So the hope is by the end of the year or so to get a like 0.x release out there for folks so people can start using it, probably find a lot of bugs. And then sometime early next year, hopefully, to ship this as a sort of 1.0 product for both the developer tools and for companies who are interested in licensing this. So yeah, those are sort of the features I wanted to show today. If folks have any more questions in the chat, I'm happy to talk about it. But yeah, that was my dry run for this. So yeah, thanks everyone. I'll stick around because I know there's a little bit of lag with the chat. Are there plans around things like authentication and similar middleware stuff? So that is a good question. Right now, the plan is to support at least sort of like bearer token type thing. So if you are sending this over, so when you're running the Poststation server, the plan is that mostly this is within a single system, so that you're not so worried about authentication because you're running your applications on the same system that is running Poststation, so it's sort of within the system, and that gives you the ability to say like, okay, well, I just won't expose that publicly, but I know that people will not do that. I'm sure they will either forward it or want the ability to make it public so that they can log in from their laptop and look at the running robot. The plan is to have sort of a pre-shared bearer key so that if you include those in your requests or some kind of information on first connection. The answer is I don't have it built in now, but that's one of those things that I definitely want to be able to have for before this goes like production quality, because as soon as you have a socket, someone's going to make that public to the world, and I don't want Poststation to look bad. So the plan is to have at least the basics. If you have opinions and want to say, hey, I need it to do at least this, let me know. But I'm pretty open to that. And I definitely will have some kind of authentication if you do want to expose like the REST API outside of the main machine. So then we have a question, is the Fial key value store exportable in a reasonable way? So for example, if you wanted to ingest some time series data into a Python notebook or MATLAB or whatever. So you can definitely use the command line API for that. You can get sort of the full dump into JSON. I'm looking at how to do a better like full dump export, or either dump everything or to be able to set some kind of query. Right now, the only way to dump it is through the command line, but the command line does allow you to get historical data as well. So you can say, give me the last million messages, and it will just spam out a million JSON items for that. So sort of, but I'm looking to have better tools for that. So I definitely know a lot of data scientists would love just an export to CSV. And since I have the schemas, I can create the columns and things like that. So it shouldn't be too big of a problem. Today, if you have the demo, you can definitely already dump historical data through the command line interface, but that does require you to do a little bit of duct tape yourself right now. So that might be something interesting for the GUI as well. I'm not promising that, but probably having a big export to CSV button would probably be a good idea there. But if not, definitely the command line will have some kind of ability for that. Same for importing. I've looked at having importing. I don't super plan to have like imports or synchronization between multiple devices. The idea is you mostly use Poststation for connecting to the embedded devices. And if you want that to be like centralized, if you've got 20 robots, that's always going to be kind of specific to everyone's setup. So it would be something where they can pull information. There's like stable records on all of the data there, so you'd be able to deduplicate it or do pagination and that kind of stuff, but send it up to whatever server you have using like an application on the embedded device itself. Scopes would probably be good for authentication. That's a good point. I have to figure out at some point what the sort of like security model is for Poststation in terms of like, is this meant to be world facing or is this meant to be firewalled at some point? Right now, sort of the recommendation is don't let it leave the system. So all of the servers that I've mentioned in sockets are only listening to like localhost right now. But like I said, someone's going to proxy it. Someone's going to do something like that. So I definitely want to have at least the minimum in terms of bearer token, but definitely longer term, I think authentication is going to be interesting in terms of exposing this either like on a local network or things like that. Marvin says he's working on a crate that does exactly the graph stuff, has tagging in operations like average and max. That's very cool. Right now, the user interface that I showed is using like web tech type stuff, so it's probably going to be using D3.js or something in that regard. I'm not good at building user interfaces, and I'm very lucky to have found someone who is, so they're going to be working on that. In the future, I'm open to other things. Yeah, all of the stuff that the like user interface uses or all the command line stuff, I've got published API and SDK crates for all of this. So the hope is that if you wanted to build your own front end on top of this, it would also be very quickly because it would be very quick to do because you wouldn't have to worry about defining all these APIs, and you just get a fairly reasonable REST API or sockets API that works fairly well. Or if you're building it in Rust, you can just talk with the native Rust crate and you can get schemas, you can get historical data, all that cool stuff. Tori, yep, you could do it with Tori. I haven't looked at packaging yet, so I might use Tori for packaging. Right now, it's still early in development, so I haven't worked at bundling it yet or anything like that. Tori could be an option. I've used that for some other projects, but it'll probably be something, WebView, Electron E for now. Might change in the future, but trying to get something useful as quickly as possible. Oh, interesting. So Marvin's the developer of Fial, the database that I'm using. So it's a thin series to ingest time state data into Fial and then query it. So Marvin, I should probably send you a DM. All the data in Fial is postcard encoded, just for compact reasons. So I don't know how easy it would be for Fial to pull it out, but we can talk about that. If you want to send me a DM on Blue Sky, I'd be interested in chatting about that. And yeah, in general, I'm using Fial. Nothing but good things to say about Fial. It's been very, very nice to use, especially since I have arbitrarily shaped data, because I'm taking arbitrary data from embedded devices and storing it. Being able to just throw those in as encoded blobs and stuff like that into the database and have it compressed and, being able to rotate out the oldest data has been really, really pleasant. Yeah. If there are any other questions, I'll stick around for another minute or two. Otherwise, I'm excited to get this in the hands of people. If you're interested in being an early user for this, send me a message on Matrix or email. Contact is on onevariable.com or contact@onevariable.com. Feel free to send me a message. I'll probably do that sort of in batches. and I might ask you what you're planning on using it for right now. But if you're interested in integrating it particularly, I'd love to talk to you sooner. If you're interested in just using it as a user, definitely would be interested. Or if you just want to play around, you can definitely use postcard-rpc right now. And if your system works with postcard-rpc, it will take you about 1 minute to get it working with Poststation. So luckily, most of the schema and communication and stuff is in postcard-rpc itself. So if you're building embedded systems, definitely try postcard-rpc. And once you have it working with postcard-rpc, you'll basically get Poststation ready to go. Okay, last call for questions. Otherwise, I'm going to go, and I hope everyone enjoys their Friday. Yeah, I hope to post more about this soon. I hope to do some more streams of actual demos. If you have things that you think would be cool to see in a demo, let me know. Otherwise, it'll probably be a lot of motors and LEDs and stuff like that. But it's just a pleasant system to throw together devices very, very quickly. So I've enjoyed using it, and I'd love to get it in the hands of more folks so that I can spend more time focusing on this and making everyone who's using it have their plumbing and ability to throw things together very quickly go much faster. So I think I'm going to end it there. Thank you very much to everyone. This recording will stay up, and I'll probably have a much fancier version of it recorded later. But thanks to everyone who asked questions, and I'll chat with you all later.